All right, let's go ahead and start chapter 8, where we're going to talk about systems of equations. And a system of equations is when you have multiple equations with multiple variables. And let me kind of give you an idea of why that might be important. So what if I gave you these two problems and I asked you to solve? If you look at the problem on the left, we notice that there is one variable, an x, and we can get that x by itself to get the equation to say x equals in order to solve it. Remember, we can subtract 4 to both sides, we can divide by 2, and we can say that x equals 3. We could always double check by plugging a 3 into my original to make sure that it is true and works in the equation. But what if I gave you the equation on the right? If you notice the equation on the right, it not only has an x, but it also has a y. And no matter what I do, when I try to figure out what x equals, there's always going to be a y in the way. Or if I try to figure out what y equals, there's always going to be an x in the way. Because there's two unknowns, two variables, it's going to be impossible for me to figure out what x is or what y is because there's too many things that are unknown. So what we might need to do is actually bring up another equation with an x and a y in order to be able to figure out what x and y equals. We call that a system of equations. Let me show you. It says here that a system of linear equations is a set of two or more linear equations with an x and a y, or two variables. A solution to a system of equations is an ordered pair, remember a point, an x comma y, that is the solution for both equations in the system. So it's the x and the y that work for both equations. So let's first start off by taking some word problems and interpreting them and writing a system of equations. And then in the next few videos, we'll actually solve a couple of different systems of equations. In example number 1, it says one number is 2 more than a second number. Twice the first is 4 less than 3 times the second. It asks us to set up a system that would help us find these two numbers. So because we have two numbers that are unknown, we would end up having two different variables. And it would be impossible for us to solve if we only had one equation with two different variables. So we need to make sure that we set up two different equations with those same two variables, a system. So I'm going to go ahead and read through these sentences really carefully and try to figure out how I can take it out of words and make it into a math equation. If you notice in the first sentence, it says one number. Well, we don't know what that number is, so maybe we can call that number x. Is, remember, is another word for equal to. So anytime I see the word is, I can change it to an equal to sign. And then the next part says 2 more than a second number. Well, I don't know what that second number is, and I don't know that it's the same as the first number, so I can't call it x. I have to call it something different. So maybe we can call it y. So let's go through and figure out how I can make that into a math equation. One number, x, is equal 2 more than a second number, y. So I'm going to say that x is 2 more than the second number. Well, if I call the second number y, then 2 more than that would really mean that I want to add 2 to whatever that number is, y. So x equals y plus 2. So that takes care of my first sentence. So what about the second sentence? The second sentence says twice the first. Remember we called the first number x? So twice that would really be 2 times x, right? Is, remember that can be translated into an equal to sign, 4 less than 3 times the second number. Remember we called the second number y. So if I want to say 3 times that, then I want to take y, multiply it by 3. But then it says that I want 4 less than that. So I want to make sure that I subtract 4 from 3 times y. So my second equation would look something like this. 2x equals 3y minus 4. Eventually, I'll show you how to solve that system of equations and figure out exactly what x is and what y is, what that first number is and what the second number is, so that it works in both of those scenarios, both of those equations. Let's first, though, set up another example, like example number 2. Example number 2 says an office supply store in San Diego sells 7 writing tablets and 4 pens for $6.40. Also, 2 tablets and 19 pens cost $5.40. Let's set up a system that would help us find the cost of each. We want to figure out the cost of these writing tablets. Maybe I can call that W for writing tablets. And I want to figure out the cost of each pen. Maybe we can call that P for pens. It says here that if we buy 7 writing tablets, 7 times however much they cost, 7W, and 4 pens, 4 times however much they cost, plus 4p, is a total of $6.40. So maybe that's what my first equation would look like. You notice that I have two variables, a w and a p, and it would be impossible for me to figure out what w is and what p is unless I have a system of equations, another equation with a w and a p. So is there another scenario that we can use to write our second equation? Well, if you look at the next sentence, it says 2 tablets, 2w, and 19 pens plus 19p is a total of $5.40. So in this example, we're using the cost of the first situation and the cost of the second situation to write our two different equations, both with w's and p's, so that I could eventually solve and figure out what w equals, the cost of each writing tablet, and what p equals, the cost of each pen. It's really important that you know how to at least set them up. We'll talk about solving in a second, and then eventually we're going to put it all together, where we have to set it up and solve it all at the same time.